Thank you very much for joining our webinar. My name is Anders Adolfsson, and I'm responsible for marketing here at Scandidos. We have a very interesting topic here today, quality control of stereotactic treatments using the Delta4 Discover. A quick agenda. We will have a short introduction about the Delta4 Phantom Plus for stereotactic treatments, which will be presented by Denis Bregnot, our clinical application specialist here at Scandidos. Then we will have a clinical case study presented by Lucie Berger, physicist from Jean Perrin Center in Clermont Ferrand. And at the end, we will have questions and answers. Any questions that you have, you can write down in the chat and we will answer them accordingly. Without further ado, I will let Denis start his presentation.
Thank you very much, Anders. Hello and welcome, everybody. I am Denis Bregnot, clinical application specialist for Scandidos France. First, I'm going to introduce the topic with a short presentation about requirements and the needs for these specific treatments. And Lucie Berger from Centre Jean Perrin in Clermont Ferrand, France, will share her experience with us. Oops. Yeah. Let's start with the key points for stereotactic treatments. We used to talk about stereotactic treatments when we use small fields or when we use hypofractionation. For the small fields, a good detector will be a detector with a sufficient 3D resolution. Moreover, we need to use extremely small detectors in order to measure high dose gradient. Regarding hypofractionation, a good detector will be a detector that has no saturation in terms of dose and no dose rate dependency. We are now going to see how Delta4 may comply these requirements. As you know, Delta4 has a double resolution. In the central area, the distance between two detectors is 5 millimeters, and in periphery, the detectors are distant by 10 millimeters. This is here a planar resolution. But of course, when we look at the Phantom, due to the overlap of the planes, the 3D resolution is better, as you can see on this view, depending on the gantry angle, of course. And if this resolution is not enough, we can merge two acquisitions. For that, we make a first measurement, then we move the Phantom by 2.5 millimeters in the transverse axis, and we add these two measurements. Now, in one plane, the detectors are distant by only 2.5 millimeters in transverse. And when we look at the 3D resolution, we now have a very small distance between two diodes, depending on the gantry. Let's take two examples. First, we use fields irradiating a sphere of 20 millimeters. This measure has been done with only one measurement. There is no merge in this case. If we include all diodes measuring more than 20% of reference dose, you can see that 100 of diodes are in the volume of interest. Oops. A second example now, this time with a very small volume irradiated. This is a sphere of 10 millimeters. Here we proceeded to a merge of two acquisitions. With this extremely small field, we still have more than 40 diodes in the volume of interest. And a short reminder on the diodes that are used in Delta4. The volume of detection is really a pinpoint. Moreover, there is no limitation in terms of dose or of dose rate. If I go back now to the slide with the key points for stereotactic treatments, we can see that Delta4 complies to the main requirements. This is a 3D detector with a sufficient resolution using pinpoint detectors. And these detectors have no saturation in terms of dose and no dose rate dependency. And on top of that, when you use Delta4, you can make a clinical analysis into the cylindrical phantom. You can locate the potential deviation regarding the structures, and you can use the DVH comparison. You also can define specific criteria for each type of structure and have a look at the gamma index or dose deviation on an individual structure. Moreover, when you use anatomy module, you can do the same into the patient and then evaluate the real impact of a deviation. Last thing, as you know, with Phantom Plus, you can use a ion chamber to complete the QA. We have at your disposal several types of inserts, including inserts for pinpoint chamber. Thank you very much for your attention. And now I'm going to let Lucie Berger talk about her experience.
Good morning, everybody. Thank you, Denis, for the introduction. Anybody listen me, I think. I'm going to present you a study of quality assurance of a stereotactic plan with Delta4 Phantom. So in our center, the treatment plans of intra or extracranial stereotactic radiotherapy are realized with dynamic conformal arc therapy field. They are calculated with the iPlan TPS from BrainLab. The reference method for pretreatment quality control is the measurement of absolute dose at the isocenter. And this dose is measured with a microdiamond detector placed in the Lucie 3D QA Phantom, as we can see in the picture. And the dose is measured for each dynamic conformal arc. Okay. So the aim of this study is to evaluate the performance of the Delta4 Phantom from Scandidos for the measurement of dynamic conformal arc therapy field. And we were then able to define evaluation criteria which proved to be suitable for the whole range of field dimension in stereotactic radiotherapy, so fields of 10 by 10 millimeter and more. We also compare the dose measures with the Delta4 to the absolute dose measured with the microdiamond detector in the Lucie 3D QA Phantom, and to the results obtained by variant portal dose image prediction algorithm. Materials and method. At the Jean Perrin Center, stereotactic radiotherapy treatment plans are calculated with the iPlan TPS, and a dedicated module called Phantom Mapping allows to calculate the plan on the Delta4 Phantom CT image. All the treatments were delivered by a Novalis TrueBeam STX linear accelerator from Varian, which a 6 MB photon beam in flattening filter-free mode, FFF. We use the Delta4 Phantom, which has been previously calibrated for the 6 FFF energy to take into account the energy response. And we also took advantage of the high resolution option of the Delta4 Phantom to double the longitudinal resolution. And we also use the PDAP algorithm and the portal imager from Varian. This is a print screen of the dedicated module Phantom mapping of ePlan. We can see the CT of the Delta4 Phantom. Different localization was studied with different equivalent field size, as we can see, 5 patients for 3 different groups with equivalent field size between 10 millimeter from 46 millimeter. The pass-fail criteria were studied with different thresholds, 20%, 30%, and 50%. And we also compare local gamma versus global gamma with 2% in dose deviation and 2 millimeter in distance to agreement. Several parameters were tested for the study treatment plans. For the analysis, we choose 4 parameters: the gamma score, the mean gamma, the number of detectors taken into account in the statistics, and the median dose. So the first results, in this histogram, we can see the local gamma versus the global gamma. As dynamic conformal arc therapy are homogeneous fields, local and global gamma score are very similar. The local gamma is more restrictive, so in the rest of the studies, the analysis is only done with the local gamma index. This histogram represents the gamma score versus the different thresholds. So in blue, threshold of 20%, in red 30%, and in green in 50%. We can see that the best gamma are obtained with the 50% threshold because detectors are in the field. But we can see when we have a little equivalent field size in this graph in green, there is not enough detector taken into account in the statistics. So the first conclusion is that a threshold of 30% and a local gamma with 2% and 2 millimeters seems to be a good compromise for all field size. So the method for portal dose image prediction, we use a source image distance of 100 centimeters. There is no saturation effect for FFF. The parameters are the same as for the Delta4. The gamma score is studied with a threshold of 30%, with gamma criteria of 2% and 2 millimeters. We also test 1 millimeter in distance to agreement. And we also note the mean dose deviation in a region of interest equal to the MLC minus 3 millimeters. Results for the PDIP. In this example, we can see the result for an equivalent field size of 10.8 millimeters. We can see that the two profiles, predict and measure, are similar, and the region of interest in the center of the picture is very small. When we look at a more larger equivalent field size of 45.8 millimeters, we can see that the profiles are also very similar, but the region of interest in which we note the mean dose deviation is more larger. In this graph, we compare the local gamma index and mean gamma index obtained with Delta4 versus PDIP. In blue, this is the Delta4 results, and in green, this is the PDIP result. We can see that the gamma score and the mean gamma measured with the PDIP algorithm are very good because of the EPID resolution, which is 0.39 millimeters. We have tested another criteria for the gamma index of 1 millimeter in green, but we can see that this criteria for the local gamma index is too restrictive for pretreatment quality control. The last result is the comparison of the dose measured versus the dose calculated for the 3 detectors, the Delta4, the portal imager, and the micro diamond detector, which is the reference. So in green, we can see our reference. And in red, we can see the result of dose measured versus dose calculated by the Delta4. And in blue, this is the result obtained by the PDIP. We can conclude that the deviation between measured and calculated dose for Delta4 and PDIP are similar to the deviation found with the reference detector, which is the microdiamond. And then the final conclusion is that for Delta4, a threshold of 30% and a local gamma with 2% 2 millimeters seems to be a good compromise for all field size. The median dose measured with the Delta4 are correct. And the advantage of the Delta4 is that the measurement is done in 2 or 3 dimensions. As Denis said previously, the physical and dosimetric characteristic of the Delta4 Phantom allow it to be integrated into a quality assurance plan, whether in classic VMAT or stereotactic radiotherapy. And we can also say that PDIP is a powerful tool for pretreatment quality control because of its very good resolution and because it is a fast and simple method. So I thank you for your attention. Hello?
Thank you very much, Lucie.
You're welcome.
Thank you very much for your presentation. Are there any questions from the audience? Please write them down in the chat or the questions. You had Lucie, you had this meeting, and Denis as well. You did this presentation for French audience a couple of months ago. What were the questions that pop up then? What were the discussions about then? Do you remember?
Denis, do you want to answer?
Yes, one question was about the criteria that we can use for stereotaxy. And there is no real answer, of course, but we can imagine that we can decrease the criteria regarding what we do with normal treatments. I don't know if somebody has something to add about this topic.
I have not seen. So, Lucie, have you, what are you using the Delta4 for any? How often do you use it for the stereotactic treatments?
We use Delta4 for every pretreatment control of stereotactic and VMAT. This is now our reference detector. Every day we use PDIP because it's very simple and fast. But if we have something wrong or PDIP are not under the tolerance, we put the Delta4 on the LINAC, and this is our reference in our center for every VMAT and stereotactic treatment.
Okay.
This is thanks to the Delta4. We have validated the PDIP. This is an independent detector, and this is our reference.
Okay. Now I've seen some questions. How big do you estimate your setup errors of Delta4 to be? This is a question from Nils Andre.
I don't understand the question.
How big do you, I mean, I guess for stereotactic treatments, the setup is more, gets more important since the fields are so small. How big do you estimate your setup errors of the Delta4 Phantom to be?
The time to do the control? No, it's
not the time. Perhaps you can explain in French, Denis.
Quelle est la précision de positionnement du fantôme en série?
Oh, Thanks to the fields of the LINAC, we can put Delta4 very precisely on the coach. There is no problem of precision to position the Delta4 on the coach. No real problem for stereotactic plans.
Okay, but you don't have any estimation that you have some.
No, I don't have any estimation.
No. Okay.